So hey Glenn, I'm Rob McBride with Brocade, and here I'm at your booth here at IDF 2014, and we want to talk about the demonstration that Red Hat is actually providing here at IDF, and from my understanding it's about service chaining.
Absolutely, yeah. And we're really excited to be part of the demonstration. We're excited to work with these key vendors that you see here. What we see at Red Hat is the power of open source, open collaboration. When we're working with large organizations like Intel and yourselves and Red Hat, what we're seeing is the ability to drive and stimulate innovation for the many, not the few, right? And once we generate that innovation upstream, we have the ability then to bring it into Red Hat bit, so to speak, and make it part of our distribution. So it really makes for a powerful ability to drive innovation to the market.
So as we're here at IDF and we're wanting to demonstrate service chaining as it relates specifically NFV and virtual network functions, one of the first things I see here of our demonstration here is, of course, Brocade's got a part with our virtual network function with our virtual router, but we also see F5's firewall and their load balancers, Riverbed, and of course some application service from Apache from a web service perspective. And the biggest thing that this thing screams at me is actually openness, right?
Yeah.
Can you kind of actually talk a little bit more about that and your guys' kind of strategy in regards to why openness is so important within the NFV and the architectures being built for NFV?
Right, and you're spot on. And the importance is because the customers are demanding it. They're demanding open source, wherever possible in their white papers, and they're coming to us kind of and trying to seek guidance on how open source can fit in and play a critical role, especially in the infrastructure. And this demonstration is just such a perfect example of working with partners in an open collaborative means, right, to build something where the whole is greater than the sum of the parts. In this case, this is service chaining, right? We're working, like you said, with Brocade and your awesome, virtual router capabilities, but we're tying that together with other partners like Riverbed, F5, and we're working again with all of these folks in an upstream community. In this case, we're using RDO, which is our upstream development environment for RHEL OpenStack platform. And we're also using our upstream community Fedora, which is upstream for our RHEL operating system. And it provides a perfect example of how you work in an open source environment. When you're doing development you're working upstream and you're solidifying, you're playing with things. And then once it gets solidified, what we do as Red Hat is we evaluate those bits on a certain cadence, and then we'll pull those down into Red Hat actual parts and make them commercially available to the public.
Okay.
So, and the market really finds that as a powerful means to drive innovation into the market.
So hey Tamer, we're over here at Red Hat's booth over at IDF 2014, and I think that what we're wanting to show here is a service chain function as it relates to NFV. A lot of it's actually based off of Red Hat and some specific components that obviously you're going to talk through here as we kind of go through the demo. So we're using OpenStack as kind of the facilitator to kind of bring these new virtual services up, which is reducing our time from, as you had mentioned earlier, in regards to having to get a physical appliance and having to deal with some of the racking and stacking of some of the more longer term types of details and configuration.
Yes, exactly. So let's suppose that for this scenario, I have actually two web servers. Suppose that the traffic actually increased more, and you need to add a new web server. So all you have to do is just go to the launch a new web server.
Okay.
And after that, you're gonna get an IP, okay, which dedicate the server. So here you mentioned that you need Apache 3, you need the web server. You're gonna boot it from the Apache, and you have all the resources like 2 CPUs, 100 gig, and so on. You mentioned all that, and you get an IP. Once you get an IP, you go to the big IP here, and you add the IP over here, okay. And voila, you have an extra web server running your show. If the traffic actually decreases later in the day, then you just destroy this one.
Okay, so what you've actually done here is not only have you been able to instantiate a new kind of a web service in the form of a web server, right? But also at the same time, we're needing to provide the network connectivity to that web service, right? Which, as you had just demonstrated, was from the F5 load balancer. But also in order to get that, outside of just load balancing, of course, there's a routing function that needs to be stitched together. So, as part of this, service chain function here, how is that actually happening? How are we instantiating the actual end user service that might be for some operator's customer, say either a web service or maybe like a CPE, if you will? How is it OpenStack is going to float in all the various different VNFs, and what's the mechanism to tie all of them together?
Actually, OpenStack is the mechanism that creates the function, it creates the services for you, it creates the VMs for you. So if I want to add an extra service, for example, I want to add McAfee sensor, so all I have to do is just get the image of the McAfee and just deploy it. Second thing, if you want to control the flows, you can control it here using OpenDaylight, for example, or one of the network controllers. So you can determine the flow of the service as you go. If you change it later, just change it later.
So that sounds awesome. So what it really sounds like we're doing from a service chain, what we're trying to demonstrate here is, not only can a telco operator be able to receive a request from their customer to stand up some sort of a, say either a CE or a CPE type of a service, but embedded within that, of course, are a variety of different other functions that we might have been deploying, more statically with hardware, which was obviously taking time. So now we're actually able to deploy virtually either a load balancer, a high-performing router, a WAN optimizer, to then be able to stitch all of them from a flow perspective to provide that service to their end user customer, while also, even on top of that, even be able to bind application services to them that an operator might be actually selling as part of their offering too as well. Is that correct?
That's true. So for the telco operators, the typical one is the EPC, IMS, stuff like that. And certain companies, they have their virtual appliances, and all you have to do is just, boot them up, and that's it. So the same thing. And the good thing is that if you have another building, another stuff to do, all you have to do is just duplicate the cluster to do that. In Intel, for example, I tried the same thing with Intel IT in order to control the whole floor in my building, and we can extend that to control the whole building.
Is it fair to say that we're able to give telco operators the confidence to know that they can choose a multi-vendor environment, be able to virtualize a number of those various different functions to address their agility, elasticity, and more importantly, their time to be able to instantiate and actually offer those services to their own customers, and have it all under a very common tool set that's got a very huge community backing.
Actually, what you're saying is true. To summarize it, really is this is viable for both the data center and telcos. And the good thing about using OpenStack with the Fedora or Rail is that you can actually flexibly add services, the flexibility to adapt to the traffic, and finally the easiness to add new services. All that can be done from the main controller of the OpenStack, and you will have it in a very fast time.
Perfect.
It depends, it can be 30 minutes, can be out, depends on your system.